Do you know why most of the time when we encounter problems in books on trigonometry or calculus problems that involve trigonometric values, they are only about the angles 0, 30, 45, 60, and 90? The reason is that as soon as you deviate from those basic angles, if you try to use 18 degrees or 36 degrees or 22.5 degrees, then you have to use these algebraic values, but they're very complicated values, and it would be a nightmare for students to work with those. But anyway, once we start actually using these values, we're going to use approximations, but it turns out that there are very good rational approximations for these values that we could use instead, and that would open up the possibilities to all sorts of other interesting angles that we could use. Now, students might not be very excited about having to do problems with pi over 8 radians, but trust me, this is going to be better for everyone because we're going to be using just rational numbers instead of algebraic numbers with radicals. The key here is that for every angle alpha, the point on the unit circle has coordinates cosine alpha, sine of alpha. So what we're going to do is find another angle alpha prime really close to alpha, such that that point is actually given by rational coordinates. And those rational coordinates are really nice because A, B, C form what we call a Pythagorean triple. So A, B, and C are integers, natural numbers, such that A squared plus B squared equals C squared. So I have done exactly that for angles pi over n, for n from 4 up to 12, and I have found angles alpha prime that correspond to some Pythagorean triple, and the angle alpha prime is equal to this angle with at least two significant digits correct. So for example, for pi over 4, I have found the triple 119, 120, 169. That gives me approximations of a square root of 2 over 2, with rational numbers. Similarly, for pi over 6, you see 120 divided by 241 is an approximation of a half, and 209 divided by 241 is a rational approximation, a pretty good rational approximation of a square root of 2 over 2. And here are the rest of the values for angles pi over 9 through pi over 12. And now, for example, we can do problems about pi over 11, because pi over 11 has sine and cosine that are really close to 7 over 25 and 24 over 25. And by the way, those two numbers, the squares, add up to 1 as they should for a sine and cosine.